All right, so today we are going to talk about solving quadratic functions by completing the square. So if you see here, it says solve x squared plus 10x equals -9. So this is not written in standard form. And if I wanted to factor this, I could. But what I would do is I would want to set it to equal to 0. So I would add 9 to both sides, and I would get x squared plus 10x plus 9 equals 0. And basically what I would do is I could draw this using the area model. So I would have one x squared tile, I would have 10 x tiles, and I would have 9 individual integer tiles. So let's see. So I start with my x squared tile. And then I know that I'm going to need to either make a square or a rectangle. So I'm going to have my 9 tiles. And that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to go ahead and I would fill in my 10 x tiles. And then I have 10 x tiles, I have 9 individual rectangles, and I have 1 x squared. And I made a rectangle. But when I'm completing the square, I'm trying to make a physical square. And squares have a even side length for the length and the width. So let's go ahead and try to reframe this into a square. So if I take this same trinomial and I want to make it into a square, I'm going to have some difficulty. So a square would have even sides of 5 and 5. So I would start out with my 1 x squared tile. I would have my 10 x tiles. And I would still have my 9 individual single tiles. So I start with my x squared this time. And then I'm going to fill in my 5 x tiles. And then my other 5 x tiles. And then I'm going to fill in my 9 individual tiles. Uh-oh, I don't have enough. I only have 9. I have all of this missing space. So I have all of this missing space right here. I don't have enough to complete the square. If I did have enough to complete the square, I would have to have 16 more tiles added. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I would have to add 16 more tiles. These 16 tiles would have to be added. So once I've added those 16 tiles, I will have completed the square. So I will have completed the square. But if I add 16 tiles, positive tiles, I also need to add 16 negative tiles. Okay, so that's what I'm essentially doing when I complete this square. Now I'm going to show you how to do that algebraically. I'm going to set this over here so it's kind of still in the picture for you to see. All right, so now what I'm going to do is I'm going to complete the square algebraically. So in order to complete the square algebraically, I want my standard form to be an ax squared plus bx equals -c. So I want to move the c to the other side of the equal sign. All right, and this happens to be written like that. So I'm going to leave it. So I start with x squared plus 10x equals -9. Now here's what I'm going to do. I'm going to turn this into a perfect square trinomial that has a length of 5 and a width of 5. So in order to do that, I need to take my 5 and I divide it in half, and I get 5 by 5, and then I multiply it to fill in that blank, and I would get 25, just like we did in class. Now whatever I do to one side, I must do to the other. And if I combine like terms, I'm going to get negative 9 plus 25 equals 16. Now if you notice, that is how many tiles I was missing to complete the square over here. Well, this x squared plus 10x plus 25 can be written two ways. I can write it as 2 factors of 5 by 5. So x plus 5 times x plus 5 equals 16. But x plus 5 times x plus 5 can be rewritten as x plus 5 squared. Now, in order to solve this, I need to take the square root of both sides. Because this is squared, so in order to isolate x, I need to do the inverse operation, or take the square root. And whatever I do on one side, I have to do on the other. So x plus 5 equals plus or minus the square root of 4, because the square root of 16 could be positive 4 or negative 4. Now I have two separate equations to help me find my x-intercepts or my roots for this quadratic function. Now I solve. Subtract 5, x equals negative 1. Subtract 5, x equals negative 9. Those are my x-intercepts, my roots, or my zeros for this quadratic function. Now let's just go over here and look. So one more time just to check. If I was to factor this original, it would be x minus plus 1, 2, 3, 4, 5, 6, 7, 8, 9, and x plus 1. Those would be my factors. And if I solve x plus 9 times x plus 1, and I set it equal to 0, I would have x plus 9 equals 0, and x plus 1 equals 0. When I solve, I would get x equals negative 9 and x equals negative 1. If you notice, these solutions are the same as these solutions. Completing the square is an alternative to factoring that works every single time.